Hello, hello. Can you all hear me?
Yeah.
Okay, good. Okay, everyone. Let's go ahead and get started. Are there any questions before I get going here over anything? I think everybody is muted, so you'll have to unmute yourself if you have a question. We're good to go then? Okay, hold on. I have a student who sent me a thing saying that she can't get into the meeting. I guess y'all didn't have any trouble, huh?
Nope.
No.
So we've got 14 people here. Let's see if Miranda shows up. Let's just give me a minute because I just want to at least respond to her. Let's see if I can do something here. No. So y'all just, you all have Zoom accounts, right? And then you just clicked on that link and you got in, no problem?
Correct.
Yeah.
It didn't even ask me for the password.
Really?
Mm-hmm.
Oh, mine did. Mine asked for the password.
Mine did too.
Mm-hmm. Okay, well.
Well, I don't even have a Zoom account. I just have the Zoom app, and I'm in the Zoom thing, so I don't think you need an account.
Well, I mean, but you have the app on your phone, right? Or
On my
or on
computer,
your-
yeah.
on your computer. So yeah, in some way you're authenticated.
When I was trying to log in, it was asking for the email also and the password.
So what email did you use?
I had to go in and look up the domain for the class. So I had to put in what you sent in the email, the domain part, the alamo.zoom.
Mm-hmm.
And then I put in the password. That's how I got it in.
Okay. What I can do is I can change the meeting where people don't need to authenticate, but I think I'd have to close the meeting and then reopen it. I don't want to do that. So let's see. I think I've got 16 people figured it out of 20, or out of 19, I think. So. Okay, well, look, we're here. Let's go on. This is all being recorded, so if someone can't get in, we'll at least they'll have the video of it. Maybe I'll take a break in a little while and try and figure it out. So any other questions over any of the aspects of like the syllabus or schedule or anything like that?
Nope.
No? Okay. So a few housekeeping things. So I was looking in our schedule. We're supposed to have our first test on Monday. And I think what I'm going to do is officially move that to next Wednesday. So I'll just say that now. Exam 1 moved to, what's that going to be? 6/17/20. And we'll do that at the beginning of class. And the reason I did that is because we still need to work out a few kinks in terms of how you're going to get your work to me. So today I'm going to give everyone an opportunity to either scan some work that you have in front of you or take a picture of it, and then you're going to upload that to the Dropbox. And I'll explain that when we get towards the end of class. But that's how you're going to do your handwritten exam work, how you're going to get it to me. So I want us to practice today. And then on Monday, if anyone's had any problems with that, we'll try and get it resolved. Because on Wednesday, when we take the test, you're going to have to get that to me like immediately after the test. So, so we're going to move it till Wednesday. And as far as what will be on it, let's see how today goes. And then I will be able to tell you what will be on the test, right? Like what topics. We got to see how far we get today. Okay, so that's the first order of business. The second order of business is back in April, we had a water leak in our house and our entire first floor flooded. And we spent like 7 weeks getting the house repaired. There's one thing that still needs to be done. And the people are actually, they were supposed to come tomorrow to do it, but they called and said that they are available today. My wife said, okay, yeah, just go to the house. So at some point here between 1 and 2, somebody's going to show up at my door to come install baseboards in our cabinets. So when that happens, I'm going to kind of step away, and I'll give you all some problems to work on during that time, just to give the guy instructions and show him where things need to be done. So I'm just giving you a heads up on that. I apologize. My wife didn't realize I was going to be busy, but it is what it is. Okay, so without anything else to talk about, let's go ahead and continue. We're going to pick up where we left off last time. We were talking about order of operations, and we talked about how we have to be real careful when you're talking about order of operations with this multiplication and division, that we always do those equally, but we move from left to right. And the same goes for addition and subtraction. Otherwise, we'll always start with parentheses first, then we'll do exponents, then we do our whole group of multiplication, division, and then addition, subtraction. So let's go ahead and just start working through these examples. I'm gonna look at number 1 over here. I hope everyone has had an opportunity to download the packet, and so that you have it available to you. So nobody asked me any questions about the homework. I'm assuming, I guess y'all had no issues with that. Let me get through some examples, and if later you do want to talk about the homework from last time, we can. Okay, so let's see here. We have this expression, okay? Why is this called an expression and not an equation? Can anyone tell me that? Like, what is the difference between an expression and an equation?
Isn't like an equation equal to 0?
Yeah, well, an equation is going to have an equal sign somewhere in there. So like examples of equations would be something like 3x plus 1 equals 4. That's an example of an equation because it has an equal sign in it. This is not an equation because there's no equal sign. It is just an expression. And so what we're being asked to do here is simplify this expression. So we want to see if we can take that big ugly thing and turn it into something nicer. So we're going to follow the order of operations here and see if we can't clean it up. So,
so you're not trying to answer it. You're just trying to simplify it.
Exactly. So it's kind of like if I wrote 2 plus 2, right? What would be a more simple way of writing that? 4, right?
Yeah. Oh, yeah.
I mean, so 2 plus 2 is 4. So that's what we're trying to do here. We're trying to take something, an expression. We're just trying to clean it up and make it a little easier to look at. So we're not trying to solve for something. We're just trying to rewrite it. So if we follow the order of operations, what should I do first?
Parentheses.
Parentheses. Okay, so I'm going to look in the parentheses here, and I'm going to try and do that first. Now, I am going to write an equal sign. I'm not creating an equation here. What I'm saying here is that this first line, okay, so this first line, it's my first line, is equal to my second line. So my second line, what I'm going to do is I'm going to rewrite everything. 5, take away 3, add 72, and then in that parentheses, I'm actually going to do 10 minus 2. And 10 minus 2 is 8, so I have now a new expression. And now I want to continue to go through the order of operations. So anytime you do the order of operations, you always want to restart. As soon as you do like one line to the next, now you restart the order of operations. So I'm going to look again. Do I have any parentheses?
Yeah, the 8.
The 8, right? Now, there's nothing I can do to 8. 8 is just 8. There's nothing I can do to simplify it. So because of that, I'm going to move on to the next thing, which is E, which is exponents. So exponents are like, if you have like 4 to the 3rd power, that's an exponent right there. We don't have any exponents here. Everything is just a number. So we don't have exponents, so we move on to the next thing, which would be do any multiplications and divisions from left to right. So do we have any multiplications or divisions?
Multiplication.
We do. We do have a multiplication. Where is it?
72.
Yeah.
Yeah, so it's not written, but it's understood. So you have to understand that this 72 right here, I'm going to go back to the first line, it actually has a dot right there. And that dot means multiplication. So even though it's not written there, it's there. So we need to do 72 times the 8. So this would be a good opportunity for us to break out our calculators and do 72 times 8. And that gives us 576. So I have a new line. Okay, my 3rd line now is 5 take away 3 plus, and now I've got the 576 that I got from multiplying 72 times 8. Okay, we start order of operations over again. We don't have any parentheses. We don't have any exponents. Do we have any multiplication or division?
No.
No more, right? So we can move on to addition and subtraction, and we're going to do addition and subtraction left to right. So we will start by doing the 5 take away 3. And so 5 take away 3 would give you 2. And then plus, we still have 576. And then finally, 578. So what we're saying is that the original expression, when it is simplified, is really just the number 578. That all makes sense?
Yep.
Okay. Let's look at the next one. Yeah, look at number 2. Yeah, I'm getting text message from someone in the class saying, hey, I can't get in. Should I go help them? Feel bad. Okay, squared. Okay, does that look pretty bad?
Yeah.
Expression, yeah, there's lots of parentheses and stuff in here. So let's start off with our order of operations. We're gonna go, please excuse my dear Aunt Sally. That's the way I was taught to remember that. Please excuse my dear Aunt Sally. Let's see who's here now. Let me see who's texting. See if they got in here. Oh no, this is not. Sorry, that was a different student, different class. Okay, so we're gonna start with parentheses. So what do we do? Because we've got a lot of parentheses, don't we?
Yeah.
How do we do this?
Do you start from left to right?
You can go left to right. Yeah, let's do that. So let's start, and I would get used to just doing one line followed by the next line, followed by, I mean, you're gonna wind up maybe having 6 or 7 lines when you're done, but it helps keep everything in order. If you try and do this all like in your head all at one time, or even try and do it like on a calculator, most of the time it's gonna get messed up. So I think you should just follow a process one step at a time. So let's do what's in this first parentheses first. So 3 take away 6. This will be interesting. This is where students start to have issues. What's 3 take away 6?
That's a negative, isn't it?
Negative. It's negative what?
Negative 3.
Negative 3. So you have to remember, you can treat it like money, right? Yeah, it's like you have $3 and then you take away, so you owe someone $6, so you're in the whole 3, right? So we've got that. Notice I kept it in parentheses, even though even though there's nothing I can do with -3, why do you think I kept it in the parentheses? Why do you think it was so important that I kept that in parentheses? Because it actually is important that I left it like that.
It's negative, and you have to eventually multiply it.
Yeah, see, we have a multiplication here, don't we? Right here, we have a multiplication after that too. If I did not write the parentheses around that -3, right? If I didn't, wouldn't that look like 2 minus 3?
Yep.
Yeah, so we don't want to make that mistake. So I'm going to keep that in parentheses, and I'm even going to put a dot here. That way I know I'm going to need to multiply that. All right, so now I'm just going to continue. I'm just going to rewrite everything. And I'm not worried about wasting paper or anything like that. I'm just going to keep writing. And now I start the whole process over again, parentheses. Well, we already know we can't do anything. We can't do anything with that -3, right? That's just sitting in there. We're just going to leave it alone. We're not going to touch it right now. And we're going to look for some other parentheses. So do y'all see that we have one big group of parentheses right there? But inside of that parentheses, we have another set of parentheses. So whenever you have a set of parentheses with another set of parentheses inside, you always do the one inside first. So I'm going to do this green one first right there. So notice I'm going to rewrite everything. 2 plus 2 times -3 minus parentheses 1 plus parenthesis and then squared parentheses squared. So all I'm going to be doing here is figuring out what 1 minus 4 is. So what is 1 minus 4?
-3.
-3. Okay, so we have another -3, just coincidentally. All right, and now we're ready to move on to the next line. Okay, so I start my order of operations over again. We already said that -3 there, there's nothing we can do with it. So I look for any other parentheses. I have, again, this big group. I have to do what's in there first, right?
Yeah.
So I cannot do anything with this -3 because it's in parentheses, but there's nothing I can do. -3 is -3. So I'm working within this parentheses. There's no other parentheses within those parentheses.
Just do the exponent.
So now I move on to exponents. I do have an exponent. The exponent here is 2. And so what I need to figure out, and I'm going to write this down below here on the side. I'll erase this when I'm done. But I'm supposed to figure out what -3 squared is. So what is -3 squared?
9.
What does it mean to square something?
Times it by itself.
Times it by itself. That means I need to figure out what -3 times -3 is. Very important that it's you're taking what's in the what we call the base. The base here is -3, and so I'm taking that -3 and I'm multiplying it by itself. And when you take two negatives and multiply them, you get a what?
Positive.
Positive. You always, so if you have the same sign, two negatives, and you multiply, you always get positive. So we get here, what? +9, right? +9. So yes, I'm going to rewrite everything again. So what should I put here? 1, and then what should I write after the 1?
We're plus.
You get rid of the parentheses, +9.
Plus
Yeah,
9.
all of this stuff we figured out was 9, right? So I'm just going to put +9. And then all of that squared. And then I start over again. So I say to myself, okay, parentheses, I can't do anything with that. How about in the other parentheses? Now we have just kind of one simplified parentheses. Can we do what's in here?
Yes.
Yeah, we can do that. 1 plus 9. I'm going to erase this. 1 plus 9, that's going to give us 10, right? So
Yep.
2 plus 2 times -3 minus. So how should I write this?
Put the 10 in parentheses.
Yeah, put the 10 in parentheses and then squared. All right. Start the process over again. How about parentheses? There's nothing I can do now, right? The -3 can't be simplified. The 2 can't be simplified, so I move on to exponents. I have an exponent here. And that exponent is actually acting on just the 10. Please, this is a critical point right here,
Yeah.
because you have 10 being squared, which means 10 times 10.
That's
You
100.
do, yeah, you do not have, see that negative right there, that minus sign? That minus sign is not being squared. So it's not like the one we had earlier. Remember we had -3 squared?
Yeah.
That -3 times -3. And that's because the negative sign was in there with the 3. And that's why we had to do -3 times -3. Here, the negative sign is outside the parentheses, and so we're only squaring the 10. And 10 squared is
100.
That's down 100. Okay, so here's where we are. 2 plus 2 times -3, and then we still have the minus sign, minus 100. All right, we're getting there. So we don't have any more parentheses that we can do anything with. We don't have any more exponents. So now we're going to do multiplication, division from left to right. Do we see any multiplication or division?
Well, the 2 times the -3, right?
2 times -3 right there. So we can do that multiplication first. So 2 plus, what is 2 times -3?
-6.
-6. So if you take two numbers and you multiply them, if they have the same sign, your answer is positive. But if they have different signs, like if one is positive and one's negative, your answer is always negative. So that's going to give us -6. How should I write this? Because I had 2, I had plus, but when we put those two together, we get -6. How should I write that -6?
2 plus -6.
2 plus -6, just like this?
And
So-
put this.
Yeah, no,
Parentheses.
go ahead.
Do you put it in parentheses or can you just?
Yeah, so this is what we would consider right here, the plus minus. That's considered bad notation because you never want to put a plus minus.
Okay.
What you want to do instead is put plus -6.
Okay.
Okay,
Why?
go ahead.
Sorry, I have a question. Why
Yeah.
can't you just do 2 minus 6?
Well, that's
Do
what
you
we're going to
have-
do in the next step. Yeah, if you were doing this on your own, you could just put 2 minus 6. That would be fine. I'm just trying to show everyone that what happens is I wanted everyone to see that notation, that we never want to write plus minus. You always want to write plus and then parentheses, negative of the number. But that just turns out to be 2 minus 6. So
Oh, I didn't even see that.
I'm going to write 2, because when you add a negative number, it's the same as taking it away.
Yeah.
So we
Now I
have
see it.
this. So I would be fine if you just went from here to here. That would be okay. Okay, so we have just subtraction left, and we're going to move from left to right. So these two take away 6.
-4.
And then we're going to take 100 away from that. So what happens when you do -4? So you owe someone $4, and then you owe someone else 100. So you owe 104 total.
Well, when it's a negative, you add. You add. Oh wait, no. Okay.
Okay, so
Only when you multiply, when you change the symbol.
yeah,
Okay.
what we're doing here is we're taking a negative number. This is why I think it's important to think about it like money. If you have -4, that means you owe someone $4, right?
Yeah.
And from there, you have another minus 100. So someone's going to come take another 100 from you.
Oh, so you
So
owe
you're
that.
going to owe 104 total.
Oh, okay.
All right. So, look at that. That problem, to do it like step by step was what? 1, 2, 3, 4, 5, 6, 7 lines. No, wait, hold on. 8 lines.
9.
Almost 9 lines, right? But that's the proper way to do it. When you take a test, okay, I want to be able to see all these steps, because if you make a mistake, then it's easy for me to assign partial credit because I can see where your mistake was. Like one of the most common mistakes that I might see on this problem would be here in green. This -3 squared, if you put here instead of +9 like -9, then everything after that's going to be wrong. But I would still give you a lot of the credit for the problem because everything else is done correctly. So you want to try and show me as much work as possible. That way I can identify the mistakes.
Yeah, that's why I had problems. A couple of the problems on the homework where I made a little mistake and it ended up being the wrong answer. You know, and
Yep.
it's like, oh
Yep.
man.
And that's just part of what makes math challenging is, you know, little mistakes will cause huge issues, but at the same time, you know, that's why we continue to practice it, is so we reduce the amount of mistakes. So just the more you do, the more confident you'll become that you're not going to make the mistake. Okay, so how about this one? That's a square root symbol. Uh-oh. There we go. I think we have everybody here now in the class. Miranda, were you the one who sent me the message? Yes? Yeah, you're good now?
Yes.
You're here, right? Okay.
Yeah, I don't know what it was doing, but it was asking for an email, and then I realized I just needed to sign in with Google, and then it went through.
Okay, good. Good. Yeah, we took a vote and the rest of the class said, let her, don't help her. Just let her, no, sorry. They didn't say that. Okay, all right, so this is kind of weird because we have this square root symbol and I hope everyone knows what that means. Like if I put here the square root of 4, that everyone understands that that's 2, because what you're saying is like what number times itself is 4. Square root of 9, that would be 3. Square root of 25 would be 5. What would the square root of 10 be? Don't know, right? Like that, we don't know. That's not a perfect square. So some things we can do easily, some things we can't. So square root of 10, we probably just use our calculator. But what's important to understand here is that when it comes to order of operations, the square root acts like a parentheses. So you've got to do everything inside the square root first. All right. So if you want, you could imagine that that's really, it's really like 5 squared minus 3 squared and then the square root. So it's like you do what's in those parentheses first. Okay, so when we're in this parentheses, we have 2 things that have exponents, don't we? We have 5 squared and we have 3 squared. So let's see what our next line would look like. If we squared those simultaneously, what's 5 squared?
25.
25. Okay, now I'm curious here. That minus 3 squared, what is that going to turn out to be? Like, are you doing -3 times -3 there?
No.
No, you're not, because there's no parenthesis around that negative.
Yeah,
You
yeah.
have,
It's 3
you
squared.
have to look at this, even though it's not written, you have to visualize this as being just the 3 being squared. So it's 3 times 3, which is 9, but you still have to subtract it. So we're going to put here minus 9. 25, take away 9. Subtraction is next, right? It's going to give us 16.
16.
And then what's the square root of 16? So what number times itself is 16?
8. I mean, not 8. 4 times 4.
4 times 4. So 4.
Yeah.
There we go. That one was a lot easier than 2, wasn't it?
Yeah.
Okay, so let's see. Let's see how. Ooh, okay. So let's do number 4.
I have a question.
Yes.
So when you got 4, you didn't leave the square root sign.
Mm-hmm.
So we take that away because if we put the square root sign over the 4, it would be 2, right?
That's right. But that means that you would be doing the square root twice. So when you're asked to find the square root of 16, what that means, just imagine it, writing this down means that I'm asking you this question.
Mm-hmm.
What number times itself is 16?
4.
So your answer is going to be 4.
Okay. All right.
So Yeah, it's the symbol itself means you need to figure out what that number is. But once you figure out that number, you're no longer asking the question anymore. So the answer is just the answer. If that makes sense. Yeah. Okay, so look at this one here. I want to just make sure we have our attention on these two symbols here. Those are just like straight vertical bars. And they act like parentheses, which means you have to do what's in those first, but they're not parentheses. Those are what we call absolute value bars. So if you see two bars, those are called absolute value. And can somebody explain to me, like if I ask you for the absolute value of a number, I'm going to give you two examples here. What the absolute value does? Can someone tell me or tell us?
No idea.
It gets rid of that negative, right?
That's right.
Yeah.
So the absolute value of a number is just whatever the number is, positive. So like the absolute value of 4 is just this number right here, but positive. But it already is positive. So the answer is 4. The absolute value of -4 is just that number right there, -4, but positive. So the answer is 4.
Oh, I see now. Okay, cool.
Yeah. So if you actually think about it, like if you can visualize this on the number line, like if you have the number 4, which was this example here, the absolute value of 4 is asking you how far away is it from 0? Like what's that distance if you were to measure it with like a measuring tape? And your answer would be 4. But if you take -4, right, which is over here on the number line, and you ask how far away from it is 0, if you got your measuring tape out there and asked how far it is, you would say it's also 4. So it's like, it almost gives you like a distance, like a distance, how far you are away from 0. And so it always spits out a positive number. Okay, with that said, let's go ahead and see if we can't take care of this. So we have these absolute value bars, and we have a set of parentheses over here on the 2 minus 3. So I'm gonna just move from left to right, and I'm gonna take care of this absolute value first. So I'm gonna look inside the absolute value, and I'm gonna do 4 minus 8 first. 4 minus 8 is -4, but it's still inside the absolute value. So I have absolute value of -4, take away 9 times 2 minus 3. So what would y'all like to do next? Y'all want to do the 2 minus 3 because it's in parentheses?
Yeah.
Yeah, okay. So we still have absolute value of -4. Take away 9 times, what is 2 take away 3? So
-1.
Yep, you have $2, you take away $3, you have -$1 now. All right, what do y'all want to do next?
Oh, left to right now, right?
We can go left to right. Well, we do have subtraction and multiplication, so we'd have to do the multiplication.
Multiple.
But do y'all want to do the absolute value of -4 right now? Like, we can actually turn that into 4, can't we?
Okay, yeah.
So let's just do that. Let's just turn it into 4.
4 minus 9.
4 minus 9 times -1. Okay, so this part's a little bit tricky. I'm going to do that multiplication first. Now, when I do the multiplication, I'm going to do 9 times -1. So I want you to just make sure you understand. I'm not including that little minus sign in the middle there. I'm going to bring it down on the next line. So my next line is going to be 4 take away, but it's going to be take away whatever I get when I do 9 times -1.
So -9?
-9. So how should I write this?
In
4
parentheses.
minus parentheses -9, like that. And this right here hopefully rings a bell from back in the past. Whenever you subtract a negative, it turns into
Positive.
or it turns into addition. So subtracting a negative is the same as adding. It's kind of weird. You can still think of it like money, but it gets a little crazy to think about this way. If we say 4, that means you got like $4 in your pocket. And then we say that somebody owes you right? Take away. Someone owes you a negative amount of money, which means that they actually owe you $9. Does that make sense or no?
Yeah. Yeah.
It's like if I owe somebody a negative amount of money, right? And that means I need to give them money. So it gets weird if you think of this in terms of money. We're done. The answer is 13, right?
Mm-hmm.
Okay. All right. So let's see what else we've got here. I mean, we're not going to have time to go through every single one of these. Which of these look interesting? How about number 6? Does 6 look good? 6 looks good to me. Let's do 6. Okay, so for 6, I have 1 plus 2 over 5 plus 1 over 3 over 2 cubed. All right, order of operations. So parentheses. Do we see any parentheses?
No.
No. However, when you have something like this, this is what we call a complex fraction because it's a fraction with fractions within the fraction. So it's like a complicated fraction. So we call it a complex fraction. Whenever you have a complex fraction, you want to treat the top, the numerator and denominator, like they're in parentheses. So that means you want to do everything on top first. You want to do everything up here, figure out what that is. Then you figure out everything down here. And then after you're done with that, you can put them together. But you have to first do the top and bottom separately. So let's start with the top. And I'm going to just do that on the side like scratch work. I have to figure out what 2/5 plus 1/3 is. And that goes back to last class. We're adding 2 fractions. Do they have the same denominator?
Nope.
No. So we can do that shortcut that we talked about. Everyone seemed to like that. We can do that thing where we go like that. So we should get 6 plus 5 over 15. I'm not going to show too much of that because that is from last time. But that should give me 11 over 15. Y'all agree with that?
Mhm.
So
Yeah.
that's what the numerator is. I'm going to go ahead and rewrite this now. This is 1 plus, now that becomes 11 over 15. Oops. 11 over 15 and then over 2 to the 3rd, like that. Okay, any questions on that?
No.
Okay, so we've run into something that is not obvious, but it's a huge problem we need to make sure everyone understands. So I'm going to write something on the side here. It doesn't have anything to do with this problem in terms of, like, I'm taking nothing from this problem, but I'm just going to write something down. I want you to tell me what you think. What is that?
4 over 2 divided by 4.
4 over 2. Okay, 4 over 2. So what would the answer here be?
No idea.
Yeah. Confusing, right? Is this a little confusing looking?
Is it
Yep.
have?
Yeah, so, okay, so let's do it one way. Here's one way we could do it. Couldn't we do this 4 over 2 first, right? 4 divided by 2. What's 4 divided by 2? Well, that's 2, right?
Mhm.
And 2 divided by 4, well, all we could do to that is reduce the fraction and become 1/2. So I heard someone say that, 1/2. That seems plausible. That seems possible. Do y'all agree?
Mhm.
Looks
Okay.
like it.
All right, well, here's another way we could have done it. What if I do the 2 over 4 first? So then it would look like this, 4 over, what's 2 over 4 as a fraction reduced?
1/4. I mean 1/2.
1/2. And now, isn't that really saying 4 divided by 1/2? Isn't that the same thing?
Yeah.
And how do we do division? What was it? Copy, dot, flip,
Yeah.
right?
So you put a 1
Copy.
on the bottom.
dot, and then flip, right? And then wouldn't we rewrite 4 as 4 over 1 and then just multiply straight across?
Yes.
And what would our answer be?
8 over 1.
8
Eight.
over 1, which is 8. That's bad. This is very bad. Because think about it, math is supposed to be pure. I mean, we're supposed to, like, you're working on some part of the world, working through a problem. If I work the same problem, right, we should get the same answers. This should not be subjective. We should all get the same thing. That's the whole reason why we have order of operations. But the problem here, the problem with this is the way I wrote it down. Do y'all see these division bars here that were underneath like that? Y'all see those? I made those the same width. And that's incorrect. That's incorrect for me to do it that way. But I was just trying to illustrate a point here. So here's how we resolve this. We have to be real careful with our notation. I can write 4 over 2 over 4, or I can write 4 over 2 over 4. Do y'all see the difference between those?
Yeah.
Okay, on the first one, you would do this first because the little bar, right, the bigger bar separates, this big bar separates the top and bottom. So you figure out the top by itself and then you bring in the bottom. So this one would be the one that gives you a half. But the bottom one, you actually do this first, reduce it to a half, and then we already know that that came out to be 8. So there's something very subtle in complex fractions, and that's the length of those division bars. You have to pay attention to them. So when we are back here on our problem, this blue bar right here is our big division bar. All right, you'll see it right here.
Mm-hmm.
And then we have above that, we have this smaller bar. Okay, so let's keep that in mind as we move ahead now, all right, in this problem. So here's what I'm gonna do. I'm gonna do 1 plus, I'm gonna leave the 11/15 alone. Here's my big bar, I'm gonna exaggerate it now. And then on the bottom, I'm gonna go ahead and just do 2 cubed. So 2 cubed means 2 times 2 times 2, right? Which is 8, right? Not 2 plus 2 plus 2, 2 times 2 times 2, which is 8. All right. Now, to do this, what I'm going to do is write 11 over 15 divided by 8. Do y'all agree that that's what that's saying there?
Yes.
And now I'm going to do copy dot flip. I really like that. Copy dot flip. When I flip 8, what do I get when I flip 8?
1 over 8.
1 over 8, right? Because that 8 is really like an 8 over 1.
Shouldn't that be 11 over 15 instead of 11 over 5?
Yeah, and why I did 5. Thank you. Okay, and now we can just multiply straight across. So we get on the top 11 and on the bottom 120. All right?
Yeah.
Okay. So now we come back here and we say, okay, this is equal to 1 plus 11 over 120. Now we have to add those two together. How are we going to add those two together? Write it as 1 over 1 plus 11 over 120. We can do that, right? And then use that shortcut for addition that we talked about last time. Here, here, and then across the bottom. So we should get 120 plus 11 over 120. So 131 over 120. Okay,
So that's the answer.
that's it. So there's plenty of room for mistakes here, right? Plenty of room for mistakes.
So you wouldn't write that as a mixed number, you would write it as the improper fraction?
That's totally up to you. You know, let me just say this. When it comes to mixed numbers, if I know a lot of you like aren't going to do more math in your life, But really, like after algebra, when you start to get to like pre-cal and calculus, mixed numbers just go away. Like we don't use them because it's kind of, well, it's almost like this. Like when I say 4 divided by 2, this division symbol, would you all agree that that division symbol is like something you learned like way back in elementary school? And then later on, we stop using it and we just do like 4 divided by 2 like that, right? Well, that division symbol is kind of like, we get rid of it at some point. Well, mixed numbers kind of the same way. Like we eventually just stop using them. Now, so to answer your question, if you left it as 131 over 120, that's just as correct as converting it to a mixed number. So I don't care personally how you give me the answer. As long as it's the correct fraction, I'm happy.
Would you be able to show us how to get a mixed number?
Yeah, so if you remember from last time, the way you do it is you have to do the long division. So you actually have to go and do that.
Okay.
So you just say to yourself, okay, how many times is 120 going to 131?
Once.
Well, once, and then that's 120 here, and then you come through and subtract, and you'll have 11 left over. And so that's your remainder. So you put 11 next to it over the divisor 120.
Oh,
So,
okay.
so you could rewrite that as 1 and 11 120ths.
Okay.
Yeah. Okay, so let's see. I'm going to let you all pick here. I'm willing to do like another 2 of these. Let me make this bigger. Yeah, so out of those right there, 7 through 15.
15.
You always go for the last one. Okay, I'll do 15. Which other ones there? Someone else pick one of those that they want me to do.
12?
12? Okay, I'll do 12 and 15. Let me do them in order. So I'll do 12 first. Oh, no, that's not what I wanted. No, I really didn't want that. Let's see if I can bring this back up there. All right, so for number 12, we have 2 parentheses, 4 take away absolute value of -5, close parenthesis, minus parenthesis 1 plus 4, close parenthesis squared. So I've got 2 sets of parentheses, so I'm going to do those from left to right. So I'm going to go ahead and do these first, or that one first. So 2 parentheses still. Okay, what can I do there inside that parentheses? What's one thing I can do just to kind of start me off?
Absolute value?
Yeah, we're going to do this absolute value first. So what is the absolute value of -5?
5.
Just 5, right? So that's like, we're asking ourselves, what is the distance? Oops. What is the distance from -5 to 0? So we know that that's 5. So this should just turn into 4. We still have the minus sign, minus, and then that's 5. And I'll just keep writing everything.
So we don't need to keep the absolute value signs after we
Nope.
solve. Okay.
Okay, I still can work within that parentheses. Like I can still clean that up. 4 take away 5, it's going to give me -1. And I'm going to keep it in parentheses, right? Because that's a multiplication right there. And then I'll have minus 1 plus 4, and then that quantity squared. I'm going to do what's in this parentheses next. So 1 plus 4 is 5. So I'm going to have 5 and then squared. So I should do exponents next, right? I should take care of that 2 right there. So am I going to be multiplying 5 times 5 or negative 5 times negative 5?
5 times 5.
5 times 5. And that minus sign will stay. So 2 times negative 1, and then this minus sign is still there, but 5 squared turns into 25. What's my next operation? No more parentheses, no more exponents, multiplication, division from left to right. Do we have any of that?
2 times negative 1.
We've got 2 times negative 1 right there. So we do have a multiplication to do. 2 times negative 1, that should give me negative 2. And then take away 25. Negative 27. You're subtracting. You owe someone $2, you owe someone else $25. You owe a total of $27. Okay, that was number 12. Let's see number 15. Okay, go ahead and go to a new sheet. Oh, good. Okay. All right, so now we're not doing number 15. We have 1/2 squared plus 1/5. Okay, we got to do what's in parentheses first. And in parentheses, I have a 1/2. And there's nothing you can do with 1/2. 1/2 is 1/2. So we move on to the next thing, which is exponents. So I have to do this exponent. So what am I going to be multiplying times itself?
1/2.
A half times a half, right? A half times a half. And how do we multiply these two fractions? Just go straight across, right? So multiply across, this should give us 1/4. So when I do this, and I square a half, I get 1/4, and then I have plus a 5th. And then to add these two fractions, because they have different denominators, I can do that shortcut. So I can go 5 plus 4 over 20, which is 9 over 20. Okay, are we good?
Yes.
Okay, so you'll have to go and practice, right? Because there's some problems here, obviously, that are different than, slightly different than what we've done. But in your homework, hopefully you'll start to solidify things. My advice to you on this would just be to slow down, okay? Take your time, because when it comes to these problems, a lot of times students will be like, I get it, I got it, no problem. He works through it, it takes forever, I'm sitting here bored out of my mind. But when you're taking a test, if you rush through it and you get it wrong, and you don't show much work, I'm gonna count off a lot, because I really expect that you can do the order of operations correctly. Can't do much math without being able to do order of operations. You've gotta have this down. So this is kind of a foundational topic that everything else you need this for everything else. All right, we're moving on to a new topic. So now what we're going to be talking about are solving what are called linear equations. Okay, so I'm going to add something to this. It's not in the title, but I'm going to add this of one variable. Okay, so we're going to take a look at solving linear equations of one variable. So what is a linear equation with one variable? Well, first of all, it's an equation. So that means we have to have an equal sign now. So it's not an expression, it's an equation. So when we're trying to identify what a linear equation in one variable is, we first need to have an equal sign for sure. Then we need to have one variable in there, which means we need to have a letter in there. Usually it's going to be X, but it could be P or M or Q or anything. Okay, but the variable is a letter, not a number. So we got to have that in the equation. And it has to be linear. So does anyone know what it means that we have a linear equation? There's something very special about linear. It has to do with the variable. Let me write an example. I'm gonna just make up my own. What do I want? There we go. That's an example of a linear equation in one variable. So let's just make sure we understand why. First of all, it's an equation because it has an equal sign. We all agree on that?
Mm-hmm.
Okay, it's one variable because we do have one variable, x. Okay, so what makes it linear is the fact that we have x raised to the first power. Now, when you write x down, it's understood that it's to the first power. It's like you don't need to write the 1 up there. But that's not the same as x squared. So if we had a 2 up here, instead, this would no longer be a linear equation with one variable. We would call this a quadratic equation with one variable. So it's always important when we're working through these things that when you're taking your test, you want to be able to look at the problem, what it's asking you, and be able to identify what you're working with, because that will help you determine the method, the path you're going to use. Because the path or the technique we use to solve linear equations with one variable is extremely different than the technique that we use to solve quadratic equations with one variable. So recognition of what you're looking at first is always like the first step. So any questions? We have an equation with one variable, and that variable has a 1 there even though we don't write the 1. Are we good with that?
Mhm.
Okay, and what we're trying to do is we're trying to solve the equation. Okay, so what we're saying to ourselves is, can we figure out what x is that makes this true? So I'll give you a very simple example. X plus 1 equals 2. This is a different problem. Can somebody tell me what x is without doing any work?
1 plus 1.
Yeah, 1 plus 1 is 2, right? So everyone agree that x is 1?
Yeah.
Right? X has to be 1. In order for that to be true, for that equation to be true, I have to replace x with 1. If I replace x with 1, then it's true. Okay, let me give you a different one to just think about. How about x plus 4 is 6? So what would x be?
2.
2, right? Because 2 plus 4 is 6. All right. So why don't I try this? How about half of x plus 3x take away 1 equals 10? Can you just look at that and give me an answer?
No.
No. So we have to have a procedure. I mean, some equations, yeah, you can just look at them and get the answer. But an equation like this, you can't just look at it and tell me, oh yeah, x is blah, whatever it is. I don't even look at that and know what the answer is. So what we need is a formal procedure and process to solve linear equations in general. So if someone gives us any linear equation in one variable, like we follow steps A, B, C, D, E, and we just kind of work our way through it, all right? So that's what we want to be able to do. But step 1 is identifying what it is. And these are all linear equations in one variable. So the method for this, to solve these, okay, so the method is to, or I'll say steps to do this. The steps to solve a linear equation in one variable is first, the first step is make sure it is a linear equation in one variable. That's always your first step. Just make sure you're looking at what you think you're looking at. Once you know that, the next step would be to simplify each side of the equation. Just putting EQ for equation. So we just got finished doing an entire section on simplifying, didn't we?
Mm-hmm.
The second step to solving a linear equation is to look at the left side by itself and simplify it, then look at the right side by itself and simplify it. So we're going to do complete simplification on both sides. Then what we're going to do after we simplify is we're going to collect what we call collect like terms on each side. Of the equation. So that means like if we have 2x added to 3x on one side of the equation, we could collect those together and make it a 5x. If we had 7 minus 3 on one side of the equation, we could do 7 minus 3 is 4. So we collect things that are the same together. And once we've done that, and we're going to work through examples, obviously, but once we've done that step, what we want to do is isolate the variable on one side. Oops, on one side. Either on that step, you get to choose which side you want to isolate the variable. So what you're trying to do is get the variable by itself on one side of the equation, anything that's not a variable on the other side. Now to do this step, you are allowed to add or subtract on both sides. So an equation is like a balance, like a scale. So if you take something off one side, you have to take it off the other side in order to maintain the balance or the equality. So on step 4, what we're going to try and do is get the variable by itself by either adding something or taking away something from both sides of the equation. And then the next step is to get a coefficient of 1 on the variable. And let me explain this. I'm just going to put var for variable. Let me explain this when we do an example. Okay, it'll make more sense once I do that. And to do this step, we are either going to multiply or divide on both sides. Okay. So if you're one of those people who like steps, there they are. Right? Those are the steps to solve a linear equation in one variable. So let's go ahead and start the first one. Do y'all need another second for that or no? Good. Okay.
Yes, please. Can we get another second?
Yep.
Just so I can finish copying.
Yep. And just start the next one down here. So we're going to do number 16. All right, there we go. Okay, so first step, is this a linear equation in one variable? Do you see an equal sign? Yeah, right. Do you see a variable? Now, you see x, right? It appears in two different places, but it's just x. It's not like there's an x and a y, or like an x and a z or something like that. It's just x. That's the only variable there. So we only have one variable. So that's check. Is that variable x raised to the first power? Well, it is because there's nothing written there. So we are looking at a linear equation in one variable. So the first step of the process is to make sure that's what you have. Okay, so now we go to step 2. Step 2 is to simplify each side of the equation. So that means let's look at the left side. Is there anything we can do to simplify this left side? So it's like order of operations. Can we do in the parentheses first? So is there anything we can do in that parenthesis? Can you take x and subtract 2? Well, you don't know what x is, do you? So you can't tell me what x minus 2 is, can you? X minus 2 is just x minus 2. You have no idea how to change that into anything else. But what are you going to do after you were to figure out x minus 2? if you knew what x was, what would be the next operation? On the left side only.
Would we distribute the 5?
Yeah, so that's a multiplication right there, isn't it? That 5 is times this. Oh, man, I don't know why it does that. There we go. That's 5 times that. And so this is the first time we've run into this, but this is where we are going to distribute. So we are going to multiply the 5 times the x, and then the 5 times the 2, or if you like, you can do 5 times -2, however you want to look at that. So 5 times the x gives us just 5x, and 5 times -2 gives us -10 or -10. So what we've done there is we've removed the parentheses, we've simplified by distributing. And then on the right side, there's nothing we can do to simplify. 4x minus 10 is 4x minus 10, whatever that is. Okay, so now what I'm going to do is move on to the third step, which is to collect like terms. So collect like terms means try and put these things together. But 5x take away 10, again, we don't know what that is, so you can't collect those together. 4x take away 10, you can't collect those together, so we're pretty much done with step 3. So the next step is to isolate the variable on one side of the equation. So this is where you have some freedom. You can either try and get the variable to be on just one side, the left side, or the right side. It's completely up to you. So I'm just going to choose to try and get the variable on the left. And what that means is that I do not want the variable on the right. I do not want 4x to be on the right-hand side. So again, this goes back to the scale. If I don't want 4x on one side, what do I have to do to get rid of it on that side?
You subtract it since it's a positive 4x. So you subtract 5x by 4x.
That's right. So because it's implied that it's a positive 4, I'm going to have to take away a 4x on this side of the equation. And whatever you do to one side of the scale, you have to do to the other. So I'm going to take away 4x on the left side at the same time. And notice I lined it up with the 5x. I lined these up. So I'm just going to now take 4x away from both sides. And when I do that, on the right side, it's nice because they just cancel each other out. On the left side, what happens if you have 5x's and you take away 4x's? So if you have 5 apples and you take away 4 apples, you should have 1 apple left. So I'm going to write that as 1x. Now, we don't have to put the 1 in front. Okay, the 1 doesn't have to be there, but I'm going to put it there just to have it. Now, what do we still have? We still have our equal sign. We still have a -10 here. And we still have a -10 over here. So those are the things that were left on the sides of the equation. Do we have the variable by itself on one side of the equation? Not quite. It's there on the left side, but there's a -10 there with it, right? This -10 is also here on the left. We only want the stuff with the variable on one side. So in order to get rid of a -10, I'm going to have to add 10 to both sides. So we're always going to do the opposite of what we see. So we're going to add 10 here, and we're going to add 10 here. And what do we get here? These go away. And these also go away, don't they? -10 plus 10, you get nothing. So what is still left on the left-hand side?
1x.
Just 1x. Well, I'm going to write just x. And then on the right-hand side, what's left? -10, add 10.
0.
Right, 0. And look at that. We have our answer. This is telling us what x has to be in order for this to be true. Now, what we could do is we could check our answer. I'm not going to require that you check your answer, but we could check it. If we go back to the original problem and we replace all of our x's with zeros, so all I did was I went to this equation here, I replaced this x and this x with 0. Then if we went through and simplified the left side, we wind up getting 5 times -2 equals, let's see, 4 times 0 would give us 0, so we just have -10 over there because that goes away. And then 5 times -2 is -10. So what you wind up getting is a true statement. negative 10 equals negative 10. That's true, so that was the correct solution. Okay. So we're going to work through another one of these. How about we work through one more? We take a break? Sound okay?
Yes.
Okay. All right, so number 18 looks pretty nasty. I think I want to change something in the problem, if y'all don't mind. I would like to change this plus right here to a minus. I think it'll be a more interesting problem if we change that to a minus. So I'll do it in red so that you know that's what I've changed. Okay, first step. It's an equation, there's one variable, and it's linear, right? So we know that these set of steps that we have are what we use for this. So we're going to simplify the left-hand side first, and then we'll simplify the right-hand side. When we look in the parentheses, 4 minus x, there's nothing you can do with that. 4 take away x, you don't know what that is. Same with the right side. You don't know, there's nothing you can do. 3x plus 5, you can't simplify. So the next thing would be to try and get rid of the parentheses by distributing like we did earlier. Like in the previous problem, we distributed. But that minus sign in front here, that minus sign right there, that really means that you have a negative 1 here. That's why I wanted to put it there, because it's implied that there's a negative 1 there. And that negative 1 has to be distributed through the parentheses like this. So when I simplify the left, it's going to be 10x. And then I'm doing negative 1 times positive 4, which gives me negative 4. And then negative 1 times negative x, which gives me positive x. So the negative out front has the effect of changing the signs of both things that were in parentheses. What was a positive 4 became negative, and what was negative x became positive x. And negative 1 in front of a parentheses always does that. It always changes the signs of things.
So if there's a negative before parentheses, it's always negative 1.
It's always negative 1. Yeah.
Okay.
And had it been like negative 2 in front, then you would distribute a negative 2 through instead. But if it's just a minus sign, it's implied that it's negative 1. Okay, so here on this one, on the right side, I've got to distribute a positive 2 through to both of those. So that should give me 6x's, then plus 10, because 2 times 5 is 10. So I've done the first step of trying to simplify, right? Now I need to collect like terms. So on the left side, we can actually collect some things together because we have 10 x's here and we want to add an x to it. So 10 x's, take and add one more x, we should get 11 x's. Take away 4 equals, and then on the right-hand side, we have 7 x's, and we're going to add to that 6 x's. So that should give us 13 of them. Right? We cannot do any more, right? That is it. We have collected like terms. So now let's isolate. Let's get the x by itself. I'm going to stick with the x on the left side. I'm going to try and keep my x's on the left. So that means I have to take out this 13x. So to take that out, I have to subtract it on both sides. I'm subtracting because it's positive 13x, so I'm taking away 13x. And I have to do that on both sides. So what is 11x take away 13x's?
Negative 2x.
Yeah, negative 2x. And then we still have minus 4, and then equals, these went away, and then 10. Lorenzo, you doing all right? You're muted right now, but you doing okay?
Yes.
kind of lost here.
Okay, well,
Um,
y'all have to ask questions. You feel
Yeah.
free to just interrupt me.
I'm just gonna go to when we go on the next question. I'll just start asking questions.
Okay. Yeah, no, I mean, that goes for everyone. You know, you'll have to just let me know, and you know, I can try and fill the holes as we go here. I mean, there is a certain pace we have to stay with in the class, but we can at least here identify any places where you might have a weakness and then address those during tutoring or office hours or something like that. Okay.
Yeah.
All right, so we have gotten the x's to one side, but I don't have x by itself. I still have this -4 here. So how am I going to get that -4 away from that x on that side? So if we have -4, to undo that, we're going to add 4. What we do to one side, we do the other, right? The whole idea here is to try and eliminate everything that's on the left-hand side so that all we're left with is the stuff that had x. What's still on my right-hand side? Just add those, right? 10 plus 4, 14. Okay. So we have done almost all the steps here. Go back and look at the steps real quick. We made sure it was a linear equation, one variable. We simplified each side by distributing. We collected like terms. We've isolated the variable by adding or subtracting things on both sides. Now we want to make sure that we get a coefficient of 1 on the variable. And I said I'd explain that with an example. So right now, the coefficient is the number in front of the x. You want your answer for that to always be a 1. So we have to somehow get rid of the -2 that's in front of the x. The tricky part is that you're not going to add 2 to get rid of the -2. You're going to take both sides of the equation and divide by -2. Divide by -2. So I'm putting a division bar there. Now, the reason why we want to divide is because this is multiplication between the -2 and the x. So if I'm trying to undo multiplication, I have to undo it with division. And we do -2 over -2 because -2 divided by -2 is 1. So it's like I had to come up with that number -2. And now I know the left side is just 1x and the right side is 14 divided by -2, which should be -7 because a positive divided by a negative is going to be negative. So we get x is equal to -7. And we could check our answer. I'm not going to, but we could check it. Now, we're going to take a break, but I just want to show you 2 quick things, 2 very, very quick things, and then we'll take our break. So I'm going to show you 2 different equations, okay? The first one's going to be x plus 3 equals x minus 7. And the other one's going to be 2x plus 4 equals x plus 2. Okay, those are 2 different linear equations in one variable, right? Let's take a look at the one on the left. Let's get the x's by themselves on one side. So I'm going to choose to try and get my variables on the left. So I'm going to try and get rid of this x right here. How do I get rid of that x on the right-hand side?
Subtract it.
Subtract, right? So I'm going to subtract an x, a single x from both sides. And when I do that, we know that they'll cancel out there. But what happens on the left-hand side? Don't the x's cancel also?
Yeah.
Yeah. So what am I left with? What's still on the left-hand side?
3.
3, and then equals what's on the right-hand side?
-7.
-7. Does 3 equal -7?
No.
No.
Okay. This is not true. That's never true, right? So what this means, whenever this happens, when you're solving a linear equation, if you ever work through the steps and at the end you get some statement that makes no sense at all, like this makes no sense, then that means that you have no solution. No solution. to the equation.
So that's the answer?
That's the answer. Because what we're saying is that if you take the original equation here and you sit there and you spend your whole life plugging numbers in, you'll never get a true statement. It will never be true, ever. There is no solution to that equation. And the way you know it is because you get some ridiculous statement that doesn't make any sense. So just keep that in mind when you're working. If you get some nonsense at the end, you know there's no solution. Now let's compare that to the one on the right. Okay, so the one on the right, hold on a second. That's not what I wanted. Hold on. Yeah, I guess I have to do it this way. Hold on a second. Let me do this. I've got to kind of change the problem a little bit. This is going to look ridiculous after we do it, but I'm changing it slightly. Okay, I just put the 2 out in parentheses around the thing on the right-hand side. So the first step I would do is clean up the right. So I would distribute through, and I'd wind up getting 2x plus 4 equals 2x plus 4. And then if I follow the steps, the next thing would be to get x by itself. So I would subtract 2x on the left and right. The 2 x's would cancel on both sides, just like it did on the problem on the left. Just like it did. And then we would get what?
4 equals 4.
4 equals 4. Now that is true, isn't it?
Yeah.
That is true. When is that true? Always, right? 4 is equal to 4 every day of the week. So what does that mean in terms of an answer? Instead of no solution, our answer is actually any number you pick will work. So that means if I go back up here to this equation in yellow, and you just give me a number and plug it in there, any number will work. So if you say plug in 3, we'll check it, it works. If you plug in 5, check it, it works. Every number you could think of will work. And so what that means is that our answer to the question, okay, our answer to the question is all real numbers. Every number you can think of is an answer. So when it comes to, in summary here, when it comes to linear equations with one variable, there are 3 possible outcomes when it comes to answers. You can have one answer, like we did in the previous 2 problems. We just had an answer, right? -7 was the answer on that one. The one before that, our answer was 0. So we can just get one number, that's our answer. Or you can get no answer, no solution. Or you can get all real numbers. So one answer, no answers, all numbers are the answer. And I think that's, go ahead.
So like during an exam, if we were to have this, would you want us to put all real numbers, or would you want us to put like any number? Or in this case, we could put.
You would have to put all real numbers.
Okay.
Because if you just gave me one answer, like if you put like x is equal to 5, then I would agree that's one of an infinite number of answers.
Mm-hmm.
But it's not the correct answer because it's not all of them.
Okay.
So in order to write all of them, you just write all real numbers. So it's 2 kind of weird situations here where your answer is going to be just a statement. You're either going to say no solution or all real numbers. Okay, it's I think good break time, yeah?
Mm-hmm.
Let's take a little, I don't know. They want 5 or 10? I don't care.
10.
10? Let's see, I've got 12:26 on my clock. Why don't we go 12:35? Okay, I'll come back 12:35 and continue. I'm going to step away for a moment also myself. Okay, everyone. So a couple of questions before I continue. So I'm going to send you, right now I'm going to launch a poll. You should get something on your screen that asks you basically yes or no. These are anonymous answers, so I will not be able to look to see who said what, okay? My first question to you is just whether or not this format of the way I'm running the class is something that you think is going to keep you engaged or not. So like keep doing what I'm doing, yes, or try something different, no. Can you all see the responses? Okay.
Yes.
And don't worry about hurting my feelings. You're not going to hurt my feelings. I want to do what works at least for a majority of the class. Okay. Okay, I think that's probably enough right now. The second question is again, yes or no, has to do with the pace I'm working in. So if you're happy with the pace, yes. If you are unhappy, no. All right. If you're happy with the pace, yes. Unhappy. So if you're unhappy, that means it's either going too slow or too fast for you. One or the other.
So the question is if we're unhappy?
No. Are you happy with the pace, the pace of how I'm working through things? So if you're happy, yes. If you're not, that means you either think I'm going too slow or too fast.
Okay, thank you.
Mm-hmm. Okay. One more question. So if you feel like I need to be going faster, then yes. If you feel like I should slow down, no. So yes, go faster, slow down, no. Okay. So you see what I'm trying to do here is I'm trying to figure out where we are, right? It's difficult for me in this environment to be able to determine each of your levels, right? So you see the results, right? Got about half the class that wants me to kind of speed up and then half the class that wants me to like slow down. So that's a difficult position to be in because, you know, I have to try and find a way to teach to the middle, but I also need to find a way to cover the material in the time that we're given. So what I will say is, you know, for the people who feel like I should slow down a little bit, please take advantage of reaching out to me for help or contacting the tutoring lab. Remember in the syllabus, there's links there to the Zoom sessions where you can get tutoring. Make sure you're taking advantage of those. Spend most of the time in here just trying to make the best sense out of everything. And then hopefully we can, you know, get it solidified when we're not in here. All right. Okay, thanks for that. Now, the next thing before I begin here, stop it, is remember between 1 and 2, I'm expecting someone to knock on my door. So when that happens, what I'm gonna want you to do, okay, so while I'm away from the desk, what I'm gonna want you to do is find a way to take at least one page that's in front of you right now. If you've been writing math, great. If you haven't written anything down today, I want you to just write something on a piece of paper. It doesn't matter what it is. And I want you to figure out a way to get that to me. All right. So the main thing though is it has to be a PDF file. It can't be a JPEG. So when I step away, I want you to go get on your phone and go to the app store and go look for something that's like if you're going to take a picture of your work with your phone, then find an app that converts pictures to PDFs. And I believe iPhones, a lot of them can do it already. I don't have an iPhone, so I think they can. And what I'll do is I'll leave the room open and y'all can talk to each other if someone finds something that works. And then right now, I'm going to send everyone in the chat. Do y'all know that there's a chat somewhere here? So everyone try and find the chat. I'm going to send you a link. Go. Why didn't I go? Okay, so in the chat, I just sent you a link. Once you have figured out how to get your picture into a PDF file, I want you to click on that link and it will give you the opportunity to upload that file. So there's a lot of things that you have to figure out how to do here. All right, you got to figure out how to take the picture and make it a PDF. Once you figure out how to make it a PDF, you got to figure out a way to get it from your phone to me. I'll send it right now. Also, that request, that link that I just sent you in the chat, I'm going to send it right now as an email through Canvas. That way you might be able to get to it from your phone.
I use Adobe Scan, and that does it.
Okay.
That makes it to PDF right away.
Okay. Dropbox link. Okay, there we go. You know what I would really try if I were you? A lot of students have no problem getting me a single page. Okay, they take a picture and they send it, they get it to a PDF and they send it to me. What you really need to be able to do come the test next week is you've got to be able to take a picture of each page and get all those compiled into a single PDF document. And I think that's challenging. So maybe today what you can do is you can try and do it with multiple pages, and let's just see how successful you are with it. Like I said, that'll be what we work on once I get interrupted here. That'll be something that you can try and work out. And I want y'all to kind of talk together. Someone said cam scanner is another one. There's a lot of different ones. I think I have an Android phone, so I think mine is actually the one that I've used is like, literally it's like, says JPEG to PDF. Like that's what it is. There's also a website you can go to that'll do it. So, all right, that'll be, that's just kind of work that we'll do once we have that free time. Let's get back to our work here.
I have a quick question.
Yeah.
Are we supposed to send you our homework?
No.
Okay.
Nope. All homework is pretty much you do it. The answers are in the back of the packet. It's just practice for you to make sure that you're going to be prepared for the exam. That's all it's there for. It's just practice. Now, you should do it. Like if you go and take the first exam and you don't do well, the first thing I'll say is, well, have you done all your homework? So, you know, you have to be careful with math because, you know, especially with topics like this, you can sit there and you can watch me do it and you're like, yeah, I can do that. Like, yeah, I got it, no problem. And then when you're actually sitting there during the test, you're like, wait a minute, maybe I don't got it, you know? So there's a difference between watching someone who knows how to do it, and I'm not trying to like talk big about myself. It's just, I'm not gonna make the mistakes. I know which way to go through the problem. It's easy to watch someone do that and be like, yeah. It's different when you're on your own. So just be careful with that. That's what the homework's there for. It's for you to sit there and struggle and be like, now I get it, now I get it. So you really learn by practicing. Okay, getting back up here, we still have more linear equations to do. So I want to take a look at, number 23. I keep doing that. Okay, number 23. Two fifths x minus 5/7 x equals x minus 1. All right, I'm going to move a little faster here, not because of the poll, but because we have to. I mean, at some point we have to just pick the pace up a little bit. This is a linear equation in one variable, and we move on to step 2. Step 2, we want to simplify. So this is the first time that we've actually seen fractions, right? And
Yep.
fractions can be difficult to work with. So when you have a linear equation, okay, not an expression, when you have a linear equation and you have fractions, when it comes to simplifying, here's what I recommend you do. You don't have to do it this way, but trust me, life will be easier for you if you do. You look at the denominators of the two fractions, and what you find is the least common denominator. Now, we did that when we were adding fractions before. We're trying to find a number that is a multiple of both 5 and 7. So can y'all think of a number that is a multiple of 5, but at the same time a multiple of 7?
35.
35. Okay, so we find this least common denominator, LCD, which is 35. And then we're going to do something very special with it. We're going to multiply both sides of the equation by 35. And this technique is called clearing fractions. So I'm going to take 35, and I'm going to multiply it times the entire left-hand side of the equation. And whatever I do to the left-hand side, I must do the right-hand side. So I'm going to take 35 and multiply it times the entire right-hand side of the equation. And notice that I put the left-hand side of the equation and the right-hand side of the equation in parentheses. I did that because if I'm going to multiply by 35, everything has to be multiplied by 35, everything. So I'm going to multiply, distribute, right? So let's see what happens when I multiply 35 times 2/5 x. And I'm going to do that on the side, at least for this first one. I'm multiplying 35 times 2/5x. Everyone see that that's the first multiplication I'm doing here in yellow? We're going to clear with that. So when I multiply, we do what we did when we learned how to multiply fractions. I'm going to write 35 as 35/1, and I'm really just going to try and multiply these two things together. So you have two choices here. You can go straight across, or you can try and reduce before you go across. What do y'all want to do? Do y'all just want me to multiply straight across and then reduce, or do you want me to reduce first, then multiply straight across?
Reduce first.
You want to do reduce first? Okay, do y'all notice that 5 goes into 5 once and 5 goes into 35 7 times?
Yep.
And now when you multiply across, you get 7 times 2, it's 14. And then what do you get on the bottom?
1.
Just a 1.
And then we still have the x there, right? Don't forget the x. So isn't that first distribution through the parentheses just 14x?
Yep.
Yep. Okay, let's do the second distribution, which will be, let's see, I'm doing it kind of in this bluish color. I'm actually not going to do the negative. I'm just going to do it on this piece, and we'll just subtract whatever it is. So I'm actually going to put the minus sign here now. Okay, let me do that work here. I'm going to do 35 times 5/7x, but again, that's 35/1. We can reduce again, can't we? 7 goes into 7 once, 7 goes into 35 5 times. And when we multiply straight across, we should get 25x. Because it's really 25/1, and then we still have the x there. Any questions on that? No? Okay, what about the right-hand side? We're done on the left, we've distributed. What about the right-hand side?
Okay, so we're going to do 35 times x.
Yeah, which gives us 35x. And then minus 35 times 1, right?
35.
Which gives us 35. Okay, now, why do y'all think I did that step?
To make it easier?
That's exactly why. I don't have fractions anymore, right? And it's so much easier to work with when we don't have fractions. You can do this by keeping everything as fractions, but it becomes very problematic. So this step is still part of step 2. It's part of the simplification. And what we did again is called clearing the fractions. There are no more fractions. Now we just go and continue through the steps. So we've simplified, now we collect like terms. Can we collect anything together? I'm on step 3. Can we collect anything together?
Oh, all the x's, right? Or no?
On the left-hand side, we can put those x's together. 14 x's take away 25 x's. Shouldn't that leave me with negative 11 x's equals 35x minus 35. So I've collected like terms, and now I'm going to sorry, get all the x's on one side.
Okay, so you can only combine x's on each side, right? You can't,
That's
it's not the whole thing, right?
That's right. You have to go left and right. The only time you can put the x's together on, when they're on both sides is to move the x over. So to get rid of it, we have to get rid of this 35x on this side. So we have to subtract it. And then what we do to that side, we do to the other side. But when you're combining them, you can only do that on one side at a time.
Okay.
So I'm going to subtract 35x here to make it go away. And then whatever I do there, I do here. Negative 11x, take away another 35x's. How many x's is that?
46.
Negative 46x equals what's still on the right-hand side?
X and minus 35.
No x's, they're completely gone.
Oh,
Because
yeah,
we had 35 of them, we took away 35.
So just negative 35?
Negative 35. Yeah, we're almost done. We're at the last step, which is to make sure we have a coefficient of 1. And right now our coefficient is negative 46. So how do we undo that? How do we get rid of the negative 46?
Divide it.
Divide it.
Divide. Be careful. You don't add 46, right? Because there's multiplication there. So the only way to undo it is to divide both sides by negative 46. Negative 46. Negative 46 over negative 46 becomes a 1x. So remember, there's a 1 in front there. You don't need to write it. And then on this side, I don't know, 35 over 46. So that, at least I know it's a positive number, right? Because a negative divided by negative is positive. Does that reduce at all?
No.
I don't think that reduces.
As a decimal, it's 0.76.
Yeah, so as a decimal, we could probably get it. But to leave it as a fraction, this is it. That's our answer.
Would you prefer us to leave as a fraction, or do you want it as a decimal?
Fraction for now. Later on in the class, we'll want to know the answer as a decimal, but for right now, the fraction is what we're looking for.
So that's the answer, x equals 35 over 46?
Yep. So when you think back, you remember when I put this problem up earlier, I did like x plus 1 equals 2, and I asked you like, what's x? And you said, okay, well, x is 1, right? And we got the answer just by looking at it. There's no way that anybody's going to look at number 23. 2/5 x minus 5/7 x equals x minus 1. There's no way anyone's ever going to just look at that and be like, oh, 35 over 46, right? I mean, you have to have a procedure to go through this and to get it, right? And this is the procedure. You know what, I'm sitting here, I'm kind of chuckling a little bit because some of y'all have your profile pics and y'all look so happy, like y'all are enjoying this so much, but it's a picture. So then I have to remind myself, you're really not happy necessarily. It's like you look so peaceful, like everything's great. Okay, yeah, so look at these linear equations. I mean, come on, there's a lot more here, right, to do. And we've done, what, 3 examples so far? So,
You can do one more example?
Yeah, so look at these here. We've done number 23. Why don't we pick one from here, and then we'll do one off the next page, and that'll be it. So what do y'all want from here?
24.
24, what do y'all think? 24 sound okay? That one it looks like there's a lot going on there. Yeah?
Yeah.
I like 24. I really like 24. I'm leaning more towards 25 though. Only because 25 also has a fraction. And it's got a good set of parentheses in there too.
That's fine.
Is that okay? 25 is harder than 24. I can tell you that right now, it's harder. So let me do 25. I shouldn't have even asked, I'm sorry. It's kind of rude of me. What do you want to do? Oh, too bad, I'm gonna do what I want to do. Okay, so number 25. 4 minus a third 2 minus 7x equals, we have an equation. Okay, there we go. Linear equation, single variable. Simplify both sides of the equation. But we have a fraction, don't we?
Yeah.
1/3. So what do y'all want to do? Anyone have a suggestion? And maybe I should say this before someone answers me. The thing about math is this. Most of the time in math, you're trying to get from point A to point B, okay? And you know, when I do a problem like this, I'm going to usually do it in like the shortest, straightest line possible to get from point A to point B, because I have the experience of this. For you, you might do something where you try something a little different, and you know, you do a slightly different approach, but you still get to the answer. You just kind of did it and maybe in a different sort of order, but you still get there. Or maybe you go off and you do a lot of weird things that I would have never done, but it still gets you to the answer. The point is this: there are many roads that will lead you to the answer. All right, there are many different roads. As long as you are doing your math correctly, like you're not making up some weird stuff that you're not allowed to do, then I can tell you that you are on a road. You're on one of these roads. But as soon as you break a rule that you're not allowed to do, you're no longer on a road from A to B, if that makes sense. So this first step right here, when I'm asking you, what would you do first? I'm asking you because that's going to determine which road we go down. And as long as it's allowed mathematically, it could be a road that leads us to the answer. So I'm curious to see what someone wants to do here, and I'll tell you whether or not that's a road that leads to the answer or not.
Distribute the 1/3.
So you want to distribute. That is perfectly fine for us to distribute. Okay, because distribution is a legal move, like it's a valid mathematical operation that we can do. So you want me to distribute the negative 1/3 through, right? Everyone okay with that? I have no problem with it. Now, should we distribute the 2 while we're at it? Like if we're going to distribute the negative 1/3, we may as well do the 2 also. Are y'all okay if like we do it on one side, we may as well do it on the other? Okay, let's do that. Okay, so we'll have 4. So that is 4. Now let's do that first multiplication. It's negative 1/3 times 2. So negative 1/3 times 2 over 1. What does that give us if we multiply that? Just go straight across.
Negative 2 over 3.
3, okay. So that's that first multiplication. The next multiplication we have to do is negative 1/3 has to hit the negative 7x. So we've got to go negative 1/3 times the negative 7 over 1x. So notice I wrote that negative 7 as a negative 7 over 1. And then just go straight across. What do you get?
7 over 3.
Positive though, right? Positive 7 over 3. X. Everyone good with that?
Yes.
All right. What about the other side? Thank you, Edward. Was that Edward?
Yes.
All right.
So then 2x minus 2.
Here we go. Okay, so that was legal. We are on a path that leads from point A to point B. What now?
Do we do the fractions?
Yeah, do y'all want to clear them?
Yeah, clear the
Be a
fractions.
good time to clear them. Okay, so you have to look at what to determine what your LCD is.
Oh, common, the bottom number is the same.
Yeah, they're the same. So if they're the same, that makes the LCD easy. The LCD is just whatever the number is.
So we just add across.
Multiply a 3 across everything on both sides. Okay.
Oh, okay. Oh, yeah, yeah.
Okay. So we're going to go 3 times the whole left side. And then 3 times the whole right side. Now, the reason we're allowed to do that, again, goes back to the idea of a scale. If we want to keep an equation balanced, whatever you do to one side, you have to do the other. So if I'm going to multiply one side by 3, I have to multiply the other side by 3. But it has the unique sort of result that it's going to get rid of our fractions. So it's going to turn out to be great for us, unless you like fractions, which I'm going to bet most of you don't. Okay, so the first multiplication distribution here, I should get 12 minus 2 plus. So I'm not going to show this step this time. I'm going to trust that that you could go on the side, do some scratch work over here. You could go 3 times 4 is 12. You could go 3 times -2 over 3 and rewrite that as 1 and then multiply straight across or reduce. You could do these multiplications. I wouldn't expect you to do them necessarily that fast. And on the other side, you get 6x minus 6. No more fractions. So the next step would be to do what? We've simplified, haven't we? So now what?
Combine like terms.
Combine like terms. So on the left side, we can actually do 12 take away 2. So we get 10. And then plus 7x. And then on the right-hand side, 6x minus 6. Can't do anything with that. So we combine like terms together. Now we try and get all the x's on one side. So I think I'm going to come in here and take away a 6x on both sides, which will kill off the 6x on the right. How many x's will we have on the left? Just one?
1.
Yeah, just one. So we have 10 plus an x equals a -6. What next?
-10 minus 6 on the other side.
Yep, so we want to still try and get that x by itself, so we have to get rid of the positive 10 over there, so we have to subtract 10 on both sides. That leaves us with x on the left, and on the right, -16. Because we're subtracting, right? We're not multiplying or dividing. And that is our answer. We already have a coefficient of 1 in front of the x, because it's just x by itself, which means there's a 1 out there. So our answer is -16. So if you go back and you look at number 24 now, the reason why 24 is not as hard is because all you have to do on 24 is distribute this negative through the parentheses. So you're distributing a -1 through. Then on the right side, distribute a 2 through the parentheses. And after that, it's just collect like terms, isolate x, coefficient of 1. I'm not saying that's nothing. I'm just saying that you don't have that other step of clearing fractions. Okay.
How did you get the 2 and 7 after you multiplied by 3?
Up here. How did I get this part right here?
Yeah.
Okay, so I'll do one of those. I'm gonna do, you're okay with the 12?
Yeah.
Okay, so you got the 12 by hitting the 4, but when I do the second one, I multiply here, right? I'm having to do 3 times, it's negative, so -2 over 3. And so I rewrote that as 3 over 1, so I can multiply straight across. But I reduced first. I said 3 goes into 3 once, 3 goes into 3 once. And now when you multiply across, you get -2 on top. And on the bottom, 1 times 1 is 1. And so you get -2. Does that make sense?
Yeah.
You sure?
Yes.
Okay.
Got it. Thank you.
Yep. And then the similar thing on the next one. 3 over 1 times 7 over 3x, and then the 3's cancel, and you just get 7x. Make sure you all are comfortable with that step, because, you know, that's definitely a place that people make mistakes, so practice. All right. I think I'm going to move on. Here's your homework. So order of operations, looks fun. And then here's your solving linear equations. We have some things in this homework that did not appear in any example I did. Do y'all see it?
The points, the decimals?
Decimals, like number 20. Maybe we should talk about one of those. Yeah, let's talk about one of those. So look at that number 20. So there's a there's a property of decimals that you should be familiar with before I start this. Let's say I take the number 4.34. Okay, let's say I give you that number. If I tell you to multiply this by 10, what does it become? Anyone know what happens when you multiply a decimal by 10?
You move the decimal over one place?
Yeah, which
So
way?
like 4.
43.4. So when you multiply a number by 10, all that happens is that decimal point right there just moves over to the right one spot. What happens if you take that number 4.34 and you multiply it by 100?
You do it twice. You
move it twice to the right. Okay? That's a very nice property of multiplying numbers by 10. All it does is moves decimal points over. So if we take this problem, number 20, and we go 8.54x minus 5.71x plus 3.8x equals -39.78. First, we make sure it's a linear equation in one variable, which it is. Then we go to simplify, right? Well, you remember how we cleared the fractions before? Here, what we're going to do is called clearing the decimal. Oh. I think we're zoom down.
It's still going. Okay.
X does a great game.
Y'all hear that?
What's in your wallet?
Hold on, let me mute it.
Now do the voice.
As soon as you step outside.
Do the oracle's voice.
The oracle's voice is like
it's
that.
It's not an old woman's voice.
As soon as you step outside.
You did the head. I want to see the whole thing. You know what the, you know. You do it because you want to
top it off. We have the Machiavellian, the vampire.
Merovingian. Hold on. With my glasses on, I'm Trinity, but if I take them off, I'm the Machiavellian.
No, you're Adam in a Spock with tips.
It's all canon.
What are you? What do you represent in the movie?
That's weird.
The oracle represents
me.
Y'all can hear me, yes?
Yeah.
Yeah.
Yes.
I think that's the first time that's happened to me, so I have no idea what that is.
It's not a bomber, right?
It could be. Could be a Zoom bomb, but I don't know. That's weird.
No,
it was
somebody's screen. Yeah.
Yeah, it was me.
Oh, David, was that you?
Yeah, I had something started playing in the background on accident. I was.
Oh, okay. Okay, cool. All right. No, that's okay because.
Yeah, sorry about that.
No, it's okay. I wanted to make sure I didn't mess, like someone didn't get in or something like that. All right. Okay. All right, so back to this, clearing fractions. Now what we're doing is we're clearing decimals. So we're going to use that same process that I just explained up here. We would like to no longer have decimals. We'd rather have nice numbers. So when we look at these numbers here, 8.54, wouldn't that be better if it was like no decimal, it was just 854?
Yeah.
And that would be nicer, right?
So
and then 571 would be better if we had 571. Let me go to this one, negative 39.78. It would be nicer if it was 3,978. Now I realize those numbers are big, but they're not decimals, so we don't have to use a calculator necessarily. So you don't have to do this. We're going to have to multiply everything by 100, right? Would you all agree?
Yeah.
So that means, and we're not actually going to do it. We're just going to use the property. We know that when you multiply everything by 100, the decimal moves over 2 places to the right. So I'm just going to rewrite the next line. What is 3.8 going to become if I move the decimal to the right 2 places?
380.
380x, and then equals negative 3,978. Do you see how I did that without doing any mathematical work? I just moved the decimal 2 places for everything. Now, when I collect like terms, I can put all those together because they're all x's. So I could do 854. I'm going to use my calculator for this. 854 of them, take away 571 of them, add 380 of them. If I do the left side, I should get 663 x's equals negative 3,978. And now I need a coefficient of 1, so I will divide both sides by what?
663.
663. So if I take this and divide by 663 and take this and divide by 663, you actually get a nice answer. The answer is negative 6. So the main idea behind that problem is just that you realize if you have decimals, you can clear them by just moving the decimal points over, but you have to do it for everything. So every one of the terms.
That was easy once you know how to do it.
Yeah, it's easier than clearing fractions. It's definitely easier because you don't have to get an LCD and then you don't have to go through the distribution part. You just move everything. While we're talking about moving decimals over, I've got some kind of off-topic but on-topic stuff. Just curious what y'all think of this. So on a number line, you know, you think about all the numbers that are on the number line, right? Obviously 0's there, 1 is there. There's other numbers in here, like 1/2 would be halfway between 0 and 1. There's 1/4, which is somewhere in there. 3/4, which was, it's like 0.75. Right, half is like 0.5. Okay, so here's my question. Can anybody think of what the number is that's right next to 1? What is the number right next to 1? This is more of just a thinking. I don't expect y'all to get this. I'm just curious to see what y'all think. Anyone want to take a stab at it? What the number is that's right next to 1?
1 and 1/4.
1 and 1/4? 1 and 1/4 would be on this side. 1 and 1/4. Here's 2.
Again, a decimal.
It could be a decimal, that's okay. What decimal do you think it would be?
1.0.
Okay, so you're actually getting the one that's on this side.
Yeah, it wants to be the before one, right?
Well, either one, but let's look at the one before 1, not the one after.
It's just 0.9 repeating.
0.9 repeating?
Mm-hmm.
So 0.9, do you all agree that 0.9 would be like, I don't know, maybe right there, 0.9? Yeah. But then 0.99 would be a little bit closer to 1?
Yeah.
You'll agree with that? And then 0.99 would be even closer? So who said that? Dalton, was that you?
Yes.
So Dalton is saying that if you have 0.9999999 forever, repeating, so we put a bar over it, you're saying that that's the number right next to 1. Do y'all think that makes sense?
Yeah.
Yeah. Okay. That's the most common answer, and it makes a lot of sense that 0.9999 forever would be the number right next to 1, but it actually is not. Okay. So I'm going to show you what 0.9999 forever actually is. Okay. So let's see if you can follow this. And I don't expect everyone to follow this. This is an off-topic thing. So let's see. I'm gonna just keep saying Dalton because he's the one who gave us 0.99. That way, I'm talking to someone here. So Dalton, do you agree that I can just assign a letter to 0.999 forever? I can just call that X, right? I'm gonna just call 0.99 forever X. Okay. So from here on out, 0.999 forever is X. Y'all good with that?
Yeah.
Okay, so let me ask you now, what's 10x? So what would happen if you multiply that decimal by 10?
Be 9.9 repeating.
Yeah, so now you've got 9.999 repeating forever, right? Doesn't matter how many nines I put there because they go forever. Yes?
Mm-hmm.
Okay, so now let me ask you a different question. If I ask you what 10x is, if you subtract from it x, tell me what you would get. In terms of x, if I have 10 x's and I tell you to take away an x, how many x's would you have?
9.
9 x's, right? But what did we just say 10x was?
9.99.
9.999 repeated, right? And what did we say x was?
0.999.
999 repeated, okay? Now, if we subtract, this is the key right here. If we take 9.999 repeated and we subtract from it just the 0.999 repeated, what are you left with?
The 9.
Just 9. Do y'all see that all of these little 0.999s, all of those cancel with those? And all you're left with is what? 9, right?
9, yeah.
But these have to be the same. Like these have to be equal. Whatever 10x is minus x has to be 9x. But we just said what 10x and x were, and we subtracted and we got 9. So we're saying that 9x must equal 9. What does x have to be then?
A 1.
A 1. X has to be 1. What does that mean?
That 1 is the closest number to 1?
Nope. That means that 0.999 forever is 1.
Oh, okay. Yeah, yeah.
And that should just be kind of like a, what? Because it doesn't seem like it would be, but it is. So the answer to the question that I gave you initially of what is the number right next to 1, there actually is no number right next to 1. If you were to grab a number and say, oh, this is it, I will always be able to find one closer to 1. Always. No matter what number you ever pick, I will always be able to find a number that's a little bit closer to 1 than the one that you think is the closest. 0.999 forever is a great guess, but it actually is the number 1, which is just, what? So there's a lot of things going on in our number line that are just weird. And I just wanted to share that with you because 10 times x moves the decimal point over 1 place, right? I can use that to show you this. So anyway, take it for what it is. It was just random, useless information. Okay, so I'm gonna leave you to your homework there for solving linear equations. And we are moving on. So we're gonna do operations with polynomials. This will be, I think, the last thing that we do here today. See, we got about 15 minutes. I don't know, the person hasn't shown up. So, there we go. All right, so before I can begin this section, which is called operations with polynomials, we need to understand what a polynomial is. So if I write 3x, let's say 3x, if I write that, is what we call a monomial. Okay, mono meaning one. All right, so what makes up a monomial is a number and then a letter, and you could have that letter to a power, so that's also a monomial. You could even have a number, a letter, and a second letter. That's a monomial. What you need is a number, multiplication, a letter, multiplication, a letter. So there's multiplications in here. To make up a monomial, number and letters with multiplication between them. No addition, no subtraction, just multiplication. That's it. That's what makes up a monomial. A polynomial is just the guy's here, just the sum or difference of monomials. All right. I'm gonna go have to answer door. Okay, so you have a task that I gave you, right? Because we knew this was coming. So I want everyone to try at this point to get into, you know, whatever app and see if you can just take a picture of a couple of your pages and get them into that Dropbox. When you put it in the Dropbox, it's gonna ask you for your name. Make sure you put your name in there. That way I can go look at your stuff. And I tell you what, let's let that be our final task because it's already 1:20. And let's just call it a day. Is that fair to everyone? We're gonna stop here.
Sounds good.
Okay, I'm gonna leave the Zoom session open so that if y'all wanna help each other at all, like what you did that worked, I'm gonna just leave it open for you. If not, I will see you Monday. I'll send out an email later today with any updates and I'll get the Zoom session posted, okay?
Thank you.
Okay, all right, I'm gonna stop the recording. Okay, y'all have a good one.
Yep.
Bye.